Okay, let me continue with the art pressure theories once again, and so far I have discussed about different cases of art pressure like at rest, active condition, passive condition, and how to find out active art pressure, passive art pressure by Wedge method and by Rankine's theory. And both the cases actually we have considered the smooth vertical wall and level backfill, and but actually the backfill will never be mostly will not be level, it can be inclined, particularly in the hilly areas when the soil will be retained by the wall, always it will be inclined. So, to find out pressure or art pressure for those cases, there is a minor modification will be required, and perhaps we can extend the Rankine's theory, and by that we can find out. Let us see one by one that before going to that I have mentioned that art pressure theories, that is Ka. That means, we have mentioned for active case sigma or I can say sigma A, suppose active Ka times gamma h, and if it is sigma passive, then again I can write Kp gamma h. So, gamma h will be common, only change Ka and Kp. So, if this is the wall height h, and then I will have pressure at any depth, if I want to find out pressure at depth h. So, sigma A at h, then it will be Ka times gamma times h, and similarly if I want to find out sigma p at h, that Kp times gamma h. So, here actually you can see now, if I put h equal to 0, then it becomes 0 and h become any values of 5 or 10 or 20. So, or in between if I vary the value, then it will be linear. So, that means your pressure diagram, art pressure diagram, lateral art pressure diagram supposed to be a triangular diagram like this. And then if this is the triangular diagram, so at any, that means at the bottommost, that means if the wall height is h, then if it is a sigma A, then your pressure will be gamma h Ka, and if it is a passive case, then sigma p will be equal to gamma h Kp. So, whatever, whether it is active or passive, accordingly you have to change this. Now, if I know this distribution like this, and if diagram become triangular, then I can find out what is the total thrust on the wall. How to find out? Just area of the triangle, then that means, so I can find out P A equal to half, and this will be gamma h Ka multiplied by again h. So, it will become half Ka gamma h square. Similarly, if I want to find out P p, then it will be half gamma h K p multiplied by h. So, it will be half K p gamma h square. So, this is the passive thrust, this is the active thrust. So, calculation is same, vertical calculation we know, vertical pressure calculation we know. If I consider a depth h, then unit weight of the soil up to that to be considered, and then finally, you know the diagram, and then you can find out the area of the triangle this become. So, this is actually since it is a triangular diagram, then this is whether it is Ka or Kp, where it will act actually, it will act you know the through the center of the triangle. So, if I from here actually it will be at a 1/3 height from the base or 2/3 height from the vertex. So, that means, this will be either 2/3 h or here 1/3 h by 3. Whether it is active or passive, the point of application of the thrust will be the same, that means h by 3 height above base or 2 by 3 h from the vertex. So, this is the one thing to be known. Second thing is whether it is Ka or Kp, only you have to change the notation, and accordingly you have to use either Ka or Kp, and if you know the value of phi, then you can find out Ka equal to 1 minus sin phi by 1 plus sin phi, and Kp will be equal to 1 by sin phi 1 by Ka 1 by Ka. So, that means whether it is active thrust or passive thrust, only you need to know phi, find out Ka, find out Kp, and then by using this you can find out thrust, and point of this value of thrust will, magnitude of the thrust will be different for active and passive case, but point of application of the thrust will be at the same location, that means h by 3 above the base of the footing. So, this is the one thing to be remembered. Similarly, if this is the dry granular cohesionless soil, then this is the procedure, but if it is layered or some other water table changes is there, then it will be little different. That has to be considered, as everywhere it is in terms of effective stress. So, for that you have to consider effective stress only. For example, so this is the wall, and this is the wall, and water table is here, though it is same soil, granular soil, but water table was here. Now, previously it was dry, but here it is water table is there. So, that means I can find out Ka, Kp at the same way, it will not change, it will not depend on earth pressure, water table condition, it depends on the soil type only, but your earth pressure diagram will change, total thrust also will change because of this water table location. How it is actually? Anytime whatever you do, whether it is sigma active equal to, it is nothing but sigma 1 dash Ka. That means, whatever I am telling initially gamma h Ka, this is gamma h actually when it is submerged, then we have to take buoyant unit weight, that is the thing actually. So, that means water table when it is there, then accordingly you have to calculate the effective stress, vertical effective stress accordingly. So, for example, up to this it will be Ka H1 gamma T, but when you go beyond this, then what will happen? Suppose at a height H2 from here, then it will be your sigma active will be equal to Ka times your H1 gamma T plus from here actually it will be gamma 2 minus gamma W into H2, that become effective stress at this point. Gamma 2 minus gamma W into H2 is the effective stress at this point, and multiplied by gamma. This is similarly, if I want to find out sigma passive, so sigma P will be again same thing, only this will change, multiplied by H1 gamma T plus gamma 2 minus gamma W H2. So, that become Kp. So, now if that means, if I want to find out pressure at this point, what will be there? Sigma active will become Ka times H1 gamma T plus gamma 2 minus gamma W multiplied by this height actually, suppose this is suppose H2 from here to here H2. So, again it will be H2. So, this is the way actually you can do, or I can write Ka H1 gamma T plus Ka, this is gamma submerged H2, gamma submerged H2. So, similarly, if it is Kp, it will be accordingly. So, that means you have to keep in mind that if there is water table, you have to take effective vertical stress, then multiply by Ka to get the lateral earth pressure, active earth pressure or lateral passive pressure. So, this is the way we have done. for active pressure, because of the soil weight this is the pressure, but here you have to remember one more point, that since water table is there and because the water also will give pressure. Suppose if you are in a tank there is some water, then water also will give pressure on the wall and the base. So, water pressure also increase like this. So, because of that, from here actually since at surface actually it will be 0, and when you go from here actually H2 depth. So, at this point your water pressure will be gamma W multiplied by H2, and here actually is supposed to be multiplied by active or passive earth pressure. For water actually active pressure or passive pressure coefficient is 1. So, it will be full multiplied by 1. So, when it will be a normal cohesionless soil, then your if this is the wall suppose, and then your active or passive pressure diagram will be something like this. But when it is a submerged, there will be 2 layer or water table is there, then you will have this. In addition to that, if there is water table from here, then because of that water pressure, that triangular diagram to be considered, that also will be the exerting pressure on the wall. So, the area of this triangle plus area of this triangle will be the total thrust of the on the wall. That is one thing. Second thing, you have to find out the point of application of the thrust. So, that means I have to find out now. I know point of application for this, point of application for. So, I can divide into number of parts now, point of application this, point of application of this, then point of application of this. So, that means different components. Now, I know the CG of different areas, actually from convenient areas like rectangle, square, triangle, these are the areas we know. Trapezium also know, but it is difficult to remember. So, your diagram is something like this. Let me erase and then I will once again I will say. So, if this is the diagram actually, if this is the diagram, you can see I can divide into, this is part 1, I can divide into part 2, I can, this is 3 and this is 4. Now, I can consider this one as P A1, I can consider this as PA2, I can consider this as a PA3, I can consider this as a PA4. So, point of application of for all cases I know. Suppose I want to find out the point of application from the base. So, I know it is at what height, I will find out area of this multiplied by this height I will multiply. Then I know this area and at what height it is acting I know. So, this area multiplied by this height I will do. Similarly, for this area at what height it is acting I can know, I know. So, I will find out the area of this multiplied by this height plus I know the area of this and at what height it is acting I know. So, I will multiply by this, then all I will be summing up, that is these are all giving moment in direction, and I will consider that suppose P A acting this way at a particular height, suppose y. So, that r multiplied by y will be equal to P A 1 multiplied by H 1 plus P A 2 multiplied by H 2 plus P A 3 multiplied by H 3 plus P A 4 multiplied by H 4. So, like that if I do, and all are known. So, P A 1 H 1, P A 2 H 2, P A 3 H 3, P A 4 H 4 all are known, only are known and R also known. R is what? Summation of all diagram, area of this diagram. So, only unknown is y. So, that means finally, if the diagram is like this irregular, then I have to find out the resultant point of application, and what is the total thrust? Area of this diagram plus area of this diagram, this is total thrust, and what is the point of application of the thrust? You have to find out this way. That means, you have to divide into number of parts, their CG location you have to find out, and then by summing the entire area I will get the total thrust, and then taking moment like this all areas with respect to base and with respect to resultant of the with respect to base, equate them, then we will get the value of y. That means, finally, you may find out the thrust is acting somewhere here, that will be your y. Okay. So, this is the way. So, that means, when it is the like water table is there, because of that earth pressure is changing. Similarly, there may be two layers, well, one layer is phi 1, another layer is phi 2. Then your gamma 1 H 1, gamma 2 H 2, like that you have to do. So, because of that the diagram may be irregular, but ultimately when it become irregular, then you have to divide into number of parts of known areas and their CG, and then find out resultant by this way. Okay. So, let me proceed to the next thing. So, that is one we will show some application actually by solving problem. So, before that, so far what we are considering that level or horizontal backfill, but if the backfill is something like this inclined with the inclination angle I, then we can imagine the failure waves like this, and in that case they are not this is actually gamma h sin phi cos I, and this on that plane this is the force stress, this is the force, So, by considering this geometry of this, one can extend the Rankine's theory to find out the value of K A K P for this inclined backfill. So, for that we can see we can failure plane will be accordingly. So, this is the one. So, with this with respect to this will be 45 degree plus pi by 2 or 45 degree minus pi by 2. So, that is the shown here, and next is, and you can see now if I draw now the failure envelope and the Mohr circle, and if I draw a line with the angle I, then it is intersecting two point actually, and their values actually you can find out which is shown in the diagram, sigma s cos I, gamma s cos square I, and accordingly using this I can establish what is the value of sigma a, K A and K P. Let me go to the next slide. You can see this again, once again I will take this one, and you can see here that O A equal to O B minus A B actually, this is actually A B. So, it is wrong, O B minus A B actually, O B minus A B. So, it become O A, and O A and then O B minus O A, and then below actually I have done O B plus A B, O B plus A B, and this is nothing but O C. See, this distance and this distance will be same, this distance will same. So, O B plus A B I have taken, and that is again O C. So, I have divided here and multiplied here. So, ultimately this is O A equal to this I can write. So, if I write this, so O B A B by O B A B and gamma is cos gamma h cos I, O C actually is gamma h cos square I. So, cos I we have written, and O B equal to, from the geometry you can find out R equal to this, B D equal to this, then A B equal to this. So, these are all I am getting geometrically, and this is of course from the soil mechanics you might have learned in detail, but may not be required, but I am just for revising actually I am taking this one. So, let me go to the next slide. So, after knowing all those things, and if I substitute, then I will get O A equal to, ultimately you can see if I substitute all those things, O A equal to whatever was there, O A minus A B, and if I substitute, then you are getting like this gamma s cos I, and then if I simplify you can see all are O D actually, or in terms of O D. So, all A D get cancelled. So, ultimately you can see cos I minus under root cos square I minus cos square phi by under root cos I plus under root cos square I minus cos square phi gamma h cos I. So, and sigma h equal to O A. So, sigma h is nothing but O A, in the figure itself you will see, and that is known by gamma h K A. Okay. So, this is gamma h K A, and so P A will be half gamma h square K A. So, that means half gamma h square cos I under root cos square this. So, this is actually your so that means your Ka equal to nothing but this. Your expression for Ka now when there was a level backfill, your Ka was 1 minus sin phi by 1 plus sin phi. Now, I have taken the backfill with angle I, and then your expression for K is this. If you put I equal to 0, if you put I equal to 0, you can see this become 1, 1 minus cos square phi means under root 1 minus sin square phi under cos square. So, it will become sin and cos I become 1. So, 1 minus sin phi it become, and this is again 1, it becomes sin phi. So, that means we have got a expression now geometrically that coefficient of earth pressure for inclined backfill, which is expression this, and since as I have mentioned that it is generalized expression, that means if I put I equal to 0, that means inclination of backfill angle equal to 0, you are supposed to get the normal active earth pressure coefficient. So, if you put I equal to 0 in this expression, you will see that K will become like this. Okay. So, that means if there is a level backfill, then we can do like this, that means your active pressure diagram will be acting like this, and but your coefficient of earth pressure will be little modified like this, and your diagram may be taken like this, like this. Next, actually you can see similarly, if an similar way if I do, then you can find out P p also equal to half gamma A square K p half gamma A square cos I, again this is actually nothing but. So, there actually it was minus here, it was plus here, now it become plus here minus here. So, as you have seen before, K p become cos I plus cos square I minus cos phi and cos I minus under root cos square minus cos I. So, this is again K p. So, cos I was there actually. So, that can be taken. So, this is actually when it is a backfill is inclined, then your earth pressure coefficient for passive case and active case already we have seen in the previous slide. Now, so far actually in the Rankine's theory and whatever we have seen that it is wall is frictionless and there is a vertical and horizontal backfill, and then somehow we could extend the inclined backfill. Now, there is a Coulomb's theory. In it, in this actually this is very much universal, that means some of the assumption can be eliminated. That means actually you can see this is as per Coulomb's theory that it can be any angle. This instead of back vertical wall, it can also incline backfill or in the back also incline, sorry, wall back also can be inclined. You can see this is very common also in many cases. So far in the Rankine's theory you have considered vertical, but this theory Coulomb's theory can consider actually inclined back, and Rankine's theory initially horizontal, but now in the from the beginning itself Coulomb's theory can take any angle of backfill, and again it was frictionless, now it can take some friction. You can see the delta angle of angle friction between the wall and the soil, that delta is also there. So, based on that again we can imagine the different failure angle, and then according to that considering the wedge you can find out the your force polygon, and then from the force polygon you can find out what is K, what is K p, and then again maximize minimize. From there you can find out earth pressure at active condition, earth pressure for passive condition, and you can find out that finally that P A as per Coulomb's theory is the value is given like this, half gamma A square, and this is the entire thing which is nothing but earth pressure coefficient for active condition as per Coulomb's theory, and this one again nothing but active art pressure coefficient for passive condition as per Coulomb theory. So, this expression is little lengthy and you can see it has so many things. It has I in it, this is the I. It has a angle of beta, that means inclination of back, you can see. It has a declination angle, this angle of friction angle of the wall friction, delta also is there. So, 3 additional thing, there only sin phi soil properties phi only was there. In addition to this, we have here delta I and beta. Now, if you put beta equal to 90 degrees, that means vertical, and I equal to 0 here and your delta also equal to 0, then you can find out that this also can be modified at the same as previous case, that means by Einstein's theory 1 minus sin phi by 1 plus sin phi, same thing will be arrived at. So, this is the one is quite accurate, actually one can get a very good estimate of art pressure because of this actual condition we are taking, but because of this lengthy expression people generally not used it. Most of the time people use Rankine's theory with minor modification. Sometime whatever it is getting by Rankine's theory little modified 10%, 20% more or less can be taken, and then based on that they can design, but otherwise one can take this Coulomb's theory as it is and one can find out art pressure which is supposed to be better one, but because of this complicated expression of art pressure coefficient, most of the time this is generally avoided, but otherwise this can be also used. So, this expression, both the expression is actually quite lengthy, otherwise there is no issue. It is very much generalized because we are taking backfill angle, we are taking wall back angle and we are taking wall friction angle. So, all 3 are included in this. So, this is actually Coulomb's theory. So, sometime what is the difference between Einstein's theory and Coulomb's theory, many times question is there. So, that can be that one has to remember and one has to keep in mind, and same time actually this formula of course one cannot remember, but you know that if you put those values it will be reduces to the Rankine's formula value or Rankine's formula also. So, like this now so far we have considered that Rankine's theory or Weiss theory or Coulomb's theory, whatever we have taken cohesionless backfill, but many times soil backfill may have both cohesion and friction. In that case, how to find out the earth pressure and then how to find out the thrust behind the wall, that will be again we need to look into that, and that maybe I will see in the subsequent few modules. And then after doing that I have to finally, after getting the pressure, and then I have to do the further the stability analysis, how wall can fail. When the wall retain the soil, then wall can have different types of failure. One type of failure is toppling or overturning, and there can be sliding like this, it can slide. This is the wall, and because of the excessive pressure it may slide like this, and there can be overturning, sliding, and then it can have bearing capacity failure also actually. That means because of this wall weight, pressure, oil pressure, then point of application of the force is passing in such a way that your pressure below the wall will not be uniform, because resistance will be there, and most of the time, and if it is designed in such way that the sometime the wall may have very little pressure one side and very much very high pressure other side. So, when the pressure become very high one side, it has to be seen that that high pressure should not exceed the bearing capacity of the soil. So, that bearing failure or bearing, that means overturning failure, shear failure or sliding failure and bearing capacity failure, that means under the loading condition whatever the pressure below the footing, that should not exceed the bearing capacity of the soil, it should have some factor of safety. And there are another type of failure, that is global failure, that means entire wall will fail with global failure, that there is another check. So, we will try to do global failure we may not able to do, otherwise that sliding failure, overturning failure and bearing capacity failure, these three things, factor of safety calculation, how to do considering the stability of the wall, we will also discuss maybe in the few subsequent module. Thank you.